Hello, this is Ms. Rickfelder. Today's lesson is on Chapter 3, Lesson 4, Slope-Intercept Form. Y equals mx plus b is the format of the equation that you're going to see. And we're going to be working on textbook pages 199 through 203. I've also included a little graphic here just to kind of solidify what it looks like on a graph. So let's get started. All right, so here you can see textbook page 199. If you could go ahead and get there in your textbook. Just remember that you're writing down the things that you see here, so you should write when I write. And you want to pause the video when it comes to practicing on your own, and then play it so that you can check any of your answers to make sure that you were correct. So the first thing we're going to talk about is what we just came from learning, which is direct variation, and then we're going to compare it to what we're learning now. So if you recall, when we worked on direct variation, so you can just write these notes in the margin anywhere you can find some room. So when we worked on direct variation, that relationship was proportional. And remember, proportional means that when we look at a graph, it goes through 0, 0. So just a little makeshift graph that you can see here. So this particular problem, hopefully you can see that line, is an example of a direct variation proportional relationship. So this would go with an equation that matches y equals mx. So that's what we did in the previous lesson. This lesson is a little bit different. So this lesson is a little different because it is a non-proportional relationship. So let's just for a second think about what this means. For the y equals mx, it means that there is a direct relationship between the y and the x value. So just think of that as only having one step, meaning I'm going to multiply all of my x's by 3 to get y. So now we're going to be working with a non-proportional relationship. So what that looks like on a graph, it's still going to be linear, but non-proportional is just saying that it doesn't go through the origin anymore. So we're going to go ahead and say that it goes right here. So this little dot right here is going to be important as we go through this lesson. So notice that the line does not go through the origin or 0, 0. It goes through some other point on the y-axis. And the slope-intercept form, or the equation for this, is going to be y equals mx plus b. So let's just take a moment to go ahead and go over what each one of these means. So remember in class, we kind of talked about this a lot. This usually means like the total or the outcome. Okay, so your y value usually means the total or the outcome. You'll also remember that the m is going to represent your slope, your constant rate of change, and whatever it is that comes right before the per something, every something, each something. Okay, so if I say $7 per day, that's going to be 7x. Remember, that's your slope. And in that same example, the x in this case would be the number of, in this case, would be days. Now, it's the number of something. Number of days, number of yards of fabric, or actually in that case it would be like number of costumes. So number of something. And this new piece that we have here is B. So we want to really focus on what that B means. And the B, I'm going to go ahead and talk about on the next slide. Before I go on to the next slide, I want to go ahead and look over the notes here. So we'll come right back to B. So it says in a non-proportional linear relationship. So that is important. That non-proportional should tell you that it doesn't go through 0, 0. So when we made these notes in class, I had everybody type or write 0, 0 and then put an X through it because that's what non-proportional means. It doesn't go through 0, 0. That doesn't necessarily mean that it's not linear because as you can see in this next spot, it says linear relationship. So remember, this makes a line. Makes a line. And so it says a graph passes through a point 0b. This is just a way of saying that it doesn't go through 0, 0. Now we have a new vocabulary word, which is that y-intercept right there. So the y-intercept of a line is the y-coordinate of the point where the line crosses the y-axis. So let's look at this. So this would be your y-intercept. So go ahead and make that note here, and then we're going to go on to the next portion. So in this slide, I'm going to focus specifically on the B. So in real world problems, and I like to start with those so that kind of it solidifies. In real world problems, the B is going to represent a starting point, a flat fee, a fixed cost. Sorry about that. and something that doesn't change no matter how many x's you get. So that'll make more sense as we go through some different things. So starting point, flat fee, fixed costs, and the number one piece of information that you need for that is going to be that it is where the line crosses the y. Okay? So where the line crosses the y-axis. Okay, so let me show you what that looks like. So if you had a little graph right here, okay, you could number this with 1, 2, 3, 4. And if I made a line that went right here, we'll pretend that that's right there on my line right there. Then as you can see, my line would be crossing the axis, the y-axis right there, and so the y-intercept would be a positive 2. So that's the y-intercept for this little line that I wrote right here, positive 2. So that's going to be important. Let's go on and see why. All right, so I went ahead and moved on to textbook page 200. So go ahead and get on page 200. And I want you to kind of look for just a second and write along with me here. So when it says a non-proportional linear relationship, remember non-proportional means it doesn't go through 0, 0. Okay, and then linear means that it makes a line. So we're going to write makes a line. Can be written in the form of y equals mx plus b. And remember in class I refer to that as the skeleton. Y equals mx plus b. Remember that's different because now it has a b. So it says this is called slope-intercept form. Write an equation, when an equation is written in this form, m is the slope and b is the y-intercept. Easy enough, right? So let's go ahead and take a look. State the slope and the y-intercept of a graph of the equation y equals 2/3 x minus 4. So all we need to do is look at the equation here. We're going to write it out to the side. Go ahead and write it out to the side. And then we want to pick out the slope and the y-intercept. Pretty easy. So this right here is going to be your slope, the 2/3. So slope is 2/3. And the y-intercept, now, I told my kids this in class, and it's really important to establish these types of habits that I'm about to tell you so that they become automatic when you're working on things. So I tell my kids to always go ahead and circle the y-intercept, including the sign. So go ahead and circle the y-intercept, including the sign, and you can do that also here in the actual problem. And the reason I want you to get in the habit of that is because when you're graphing equations from slope-intercept form, you're going to always start with B. You're going to always start with where it crosses the y-intercept. So get in the habit now of writing, or circling rather, that B, including the sign. Be sure to circle it, include the sign. So -4 is going to be our y-intercept. So that means if I were to put this on a graph, I would go down 4 spaces and put a dot on that y-axis, the one that goes up and down. So let's go ahead and take a look at this. When you're doing this, you want to make sure to include the sign. That's really important. All right, so if you circle the y-intercept and then underline the slope, that will give you something to go off of. So let's go ahead and pause your video for just a moment so that you can try A, B, and C. Go ahead and do that now. So right away you should have circled the y-intercept. In this case it's going to be 3. So I'm going to write y-intercept is 3, and then I'm going to go ahead and change colors for your benefit here. Let's see if we can get like a purple in there. Actually that's close, hang on. So now we're going to go ahead and write the slope. So now keep in mind, don't forget, probably the biggest mistake in this portion is not including the sign. So the slope here is -5, or you could have it as -5/1. Either of those would be fine. So how did you do? Try the next one. So the y-intercept is going to be -6, and the slope is going to be 1/4. Now just to reiterate, I talked to my class about this, 1/4, I say it like that because I don't want you to say it as a fraction, because really it's not a fraction. It's up 1, right 4, up 1, right 4. So you really want to be in the habit of looking at the number 1/4 as a directional thing and not a fraction. So how did you do on that one? Check your next one. Now the next one is a little different just because you're not used to seeing it with just the -x. So let's start with the easy part, which is going to be the y-intercept. So as you can see, we've already circled it. The y-intercept is 5. And then the next part is going to be the slope. And you can see that I've already underlined it because if you do the same thing every time, that's what will trigger your mind to do it correctly on the test or quiz or even on your homework. So when you look at negative x, remember the only time that you're going to see an x without a number in front of it is when it's really a 1. So don't forget the negative sign. The slope for this one is -1 or -1/1. Okay, so did you get that one right as well? Let's go ahead and move on. Example 2 says to write an equation of a line in slope-intercept form with a slope of -3. So I'm going to go ahead and underline my slope of -3, and it says a y-intercept of -4. So I'm sticking with those same colors. As soon as you see write an equation, put a box around that, and slope-intercept form, put a box around that. As soon as you see that, off to the side, I want you to write that skeleton formula. Sorry, I'm having some recording difficulties. Y equals mx plus b. As soon as you see write an equation in slope-intercept form. So from there, let's go ahead and just look at what we've circled and outlined. So I'm going to stay in black for the things that don't change. Y isn't going to change. I'm going to leave a space for m, and the x doesn't change. So notice I don't write the plus yet. The reason I don't write the plus yet is because if you look at our y-intercept here, it's actually -4. So we're going to write it as -4. So that's why I don't write the plus yet. And then for the slope, we're going to go ahead and look at that. And it says the slope is going to be -3. So your final answer here should be y equals -3x minus 4. And it's y equals -3x minus 4. I don't know if I said plus 4 before or not. So -4 for sure. Just be sure that you've written your answers, if you can, for A, B, and C over here on the lines. If not, that's okay. It just makes it harder to find. All right, so before we look on page 200 at example 3, I just want to go ahead and go back for just a second. Let's see. Hang on one second. Okay, so I want you to see on here where it says, notice this step right here where they said plus and then a -4, but I want you to notice that the final answer that they gave is this right here. We don't want plus a -4, excuse me, for your slope. So that's a no-no. I'm sorry, for your y-intercept. That's a no-no. So make sure you cross this part out. This is not what's happening. We want to make sure that that's our final piece for our y-intercept. So here we are with example 3. So in example 2, we were taking it from, and it said to write an equation from words, basically. Now we're going to write an equation in slope-intercept form from a graph. So again, as soon as I see that write an equation, I'm going to go ahead and put a box around that. And as soon as I see slope-intercept form, I'm going to put a circle or a box around that. And we're doing it from a graph. So this makes it a little bit more tricky. So the very first thing that you're going to want to make sure that you do is to find the y-intercept. That's always the first thing. So find the y-intercept. Actually, because I'm trying to be consistent with you, the first thing I want you to do is make sure you write that skeleton. So as soon as you see write an equation in slope-intercept form, write your skeleton off to the side. The second thing is going to be to find the y-intercept. And remember, the y-intercept is where the line crosses over the y-axis, and the y-axis is that vertical line. So again, the y-axis is going to be wherever the line crosses over the vertical, the y-intercept is where it crosses the y-axis. So right here, go ahead and circle that. And I want you to see that from 0, 0, which is the origin, we're going to go, we're going to go up 1, 2, 3, 4. So that means that since we went up, it's positive, and we went up to 4, so it's +4. So that's our y-intercept. So right down here, let's start by writing the things that don't change, which is the y equals and the x. We don't want to write plus or minus until we know what that y-intercept is. Now we do know now what it is. It's +4. So let's go ahead and fill in +4. Then we need to find the slope. You want to go ahead and add that note on the left-hand side in the margin where I've added it there. That's to find the slope. So in order to find the slope, I'm going to go ahead and erase what I have here so that you can see a little better. So I'm just going to go ahead and erase that. Now to find the slope, I'm going to zoom in here so that you can see. So we need to find a perfect point. So remember, I talk about the perfect point being in the crosshairs. So that's a perfect point. Label it as such. All right, so I have my perfect point, and then I also have my y-intercept, which is where I'm starting. I just made that a red dot. So now to find the slope, we're going to do the rise over the run. Now, rise and fall means the same thing. In the past, I've had students really struggle with knowing when it's a negative slope and a positive slope. So I'm going to teach it a little different this year. So right now, I want you to see that we do go down 1. So that's actually where the negative 1 comes from. Go ahead and write that. When you go down, it's negative. When you go left, it's negative. Okay, so down 1, that's the rise over run. And then we're going to go 1, 2 to the right. So that's a positive 2. So that means that our slope is going to be negative 1 over 2, okay? Now, even if you somehow missed that it was down and you forgot, oh, darn it, the negative sign, before you write any of the equations, I want to make sure that you identify whether or not ski bird would be going up or down. So remember, when we're looking from left to right, just like you read a book, you want to think, is ski bird going to be going downhill or is he going to be going uphill? If he's going downhill, it's going to be a negative slope, hence the negative right there. If he's going uphill, it's going to be a positive slope. So just do that quick check, and then since you do know he's going to be going downhill, it's going to be negative 1 over 2. Again, the other error is usually not putting the rise over the run. All right, so now we're moving on to textbook page 201. Go ahead and get to that page now. And I'd like you to try D and E on your own. So I want you to annotate the problem. That means to do your circles and your underlines, just like we've been talking about. Push pause, annotate the problem, show your work on the graph, and then push play to check your work. All right, so let's go ahead and look at D. Write an equation. Oh, okay, that's first. And then it's going to say write an equation in slope-intercept form. Okay, that was the second thing. So immediately for D, I'm going to write y equals mx plus b. So this is right away. And what I want you to understand is that problem D is going with the graph. See how it says graph shown? That means problem D goes here. And problem E is from the words, just like we looked at in the previous examples. So now for problem D, it's asking you to write an equation in slope-intercept form using the graph. So again, the very first thing we always want to find is that y-intercept. So let's go ahead and take a look. From the origin, which is 0, 0, we can see that this line crosses the axis right here. So we're going to count down 1, 2. So that means that is at negative 2. So I'm going to write the things that don't change. Y equals something x. And now we know we're going to have minus 2. Okay, minus 2 tells us it's negative 2. That's where it crosses the line, the y-axis. So now the next part that we're going to look for is the slope. Went ahead and erased what I did on the graph so that we could find the slope. So the perfect points that they used here, let's go from right here where we were at to up here. So now we want to count. Remember, we always want rise over run, so I typically want to start with the rise. So 1, 2, 3, 4, 5. Make sure that you put your pencil on the first dot and only count when you hop. So I went up 5, so that's plus 5. And then I'm going to go 1, 2, 3. Sorry, that was a little messy. 1, 2, 3. Now you can see it. So that means I went to the right 3. So if I'm doing the rise over the run, remember that's 5 over the run of 3. So when I take it over here to my equation, I'm going to write that as 5 over 3. So it should be y equals 5 over 3x minus 2. Now let's go ahead and look at the word problem. Arguably the word problem is pretty, I think it's a little easier. So let's write an equation of a line in slope-intercept form. So again, that tells me, if you notice in math, I try and do the exact same thing every single time. You should as well. That's how you create those paths in your brain to kind of be more automatic with it. So y equals mx plus b. I'm immediately going to write the things that don't change. Y equals something x. We're just going to leave that there for now. So now it says the slope is 3 over 4. So I'm going to underline my slope right there. And then it says the y-intercept is negative 3. So as usual, I'm going to circle the negative 3. So minus 3 is going to go there in the y-intercept spot. And then they said the slope was 3 over 4. So my final answer for this one should be y equals 3 over 4x minus 3. How did you do? Make sure that you review the video again if you didn't do very well on those two problems. All right, let's go ahead and look at interpreting the y-intercept. So before we start this, I want you to just write a couple things in the, about that, I got cut off. So I want you to write a couple things in the margin here. So words that usually tell you what's going to go with the x is going to, these words are going to be each, every, and per. typically when you see these words, you know that this is going to go right before the x. That tells you that this is your slope, this is your constant rate of change, whatever you want to call it, it's what goes before the x. So if I tell you it's going to cost $6 per ticket, that would look like this, 6x. Okay, 6x. So now I'm going to go ahead and erase that so that you can stay with me for this actual problem. The other thing is, remember from a previous slide when I talked about flat fee, fixed cost, things like that, things that don't change no matter how many things you buy, there's that one-time charge. That's going to be your y-intercept. So let's look at this problem. It says they want you to write an equation in slope-intercept form. So immediately you know you're going to be using y equals mx plus b, okay, to relate to the real-world situation, rate of change, and the y-intercept represents the initial value. So student council is selling t-shirts during Spirit Week. It costs $20 for the design, so circle that. We don't know exactly what it means yet until we move on to the next part. And $5 to print each shirt. I need you to hear the each shirt. That's important. This is probably the most important skill with y equals mx plus b, is being able to accurately pick out which one goes in for the slope and which one goes in for the fixed cost. So let's think about that. What thing applies to each shirt? Well, it's the 5. So in that problem, y equals mx plus b, let's go ahead and write it off to the side. Mx plus b. We're going to leave the things that stay the same, y equals x, and then we're not going to do the plus or minus yet. So let's first find, for this one it's a little easier to find whichever one goes with the slope, or which one is the slope. So $5 each shirt, that means you would put a 5 right here. In this situation, what does the 5 represent? I'm sorry, what does the x represent? That's going to be the number of shirts you order, right? Make sure that you add that there so that you're getting the full picture of what this problem is about. So it's going to be $5 per shirt, and if you notice, it says it costs $20 for the design. Well, that $20 for the design, that's a fixed fee. You only pay that one time. So $20 for the design. So 5x, y equals 5x plus 20, okay? So you can see that the slope is 5, or 5 over 1, and the y-intercept is 20. Now this last part for 5, it says the slope represents, you do need to understand this, the slope represents the slope 5 represents the cost in dollars per t-shirt. You need to be able to interpret. So this is your answer for the interpret part. Make sure that you put a big star right here because this is the part that nobody does very well. So interpret is the slope 5 represents the cost in dollars per t-shirt. So when you're talking about the interpretation, you need to write what it represents and you need to write the unit. And what I mean by the units is in dollars. I know this is going to come off the page, but that's okay. And then when they talk about the y-intercept, it says the y-intercept 20 is the one-time charge in dollars for the design. So again, what does it represent and what are the units? Okay, so it's really important that you know how to do that. All right, so we're on to our last example, which is right here on page 202. So you're going to go ahead and pause the video now so that you can work on this problem. Now I want to point out they want you to graph the equation. So you're going to graph it right there on the graph. And then you need to interpret the slope and the y-intercept. So that interpret is going to go along with those word problems there on example 4, I believe it was. Let me just look back and make sure. I'm sorry, example 5. So the interpret answer needs to follow the example 5. All right, so now let's go ahead and annotate the problem. Hopefully you did well. It says a taxi fare can be determined by the equation y equals 0.50x plus, bless me, goodness, sorry about that. So y equals 0.50x plus 3.50. So I'm going to pull that out to the side, and before I even start, I'm going to kind of interpret what that means. So let's think about that. When it says a taxi fare, y, so that means that, what does it mean, a taxi fare? So we're not just going to write a taxi fare here for y. We're going to say that that's going to be the total cost, so you should be writing this, for the taxi fare. Okay, so it's important that you understand that that's going to be the total, that's the y. So once we do the multiplying and the adding, it's going to be the total cost that a person pays. So the total cost can be determined by this equation where x is the number of miles traveled. So let's go ahead and add that. X is going to be the number of miles traveled. Okay. All right, so now we only have two things really to interpret, and we know that one is attached to the x, okay? So let's look at that one attached to the x, that's 0.50. Well, we're talking about money here, so let's think. That means it's gonna be 50 cents per what? Per what? Sorry about that, I had to change colors. So it's gonna be 50 cents per mile. Okay, the reason it's 50 cents per mile is because remember it's attached to the x, and x is the number of miles. So we know that now. So that must mean since the 3.50 we know is a fixed rate, meaning it doesn't change no matter how many miles you drive, so the 3.50 is really the cost to take the cab. So that's going to be the flat fee to take the cab, or the taxi rather. So what that means is that before the cab driver even starts driving, I initially have to pay a $3.50 flat fee, and then I pay 50 cents a mile. There are tons of things in real life that work this way. So you want to make sure that you understand this. So now we want to graph it. Well, do you see any 50 cents on here? No. So instead of it being like that, first we need to know where we start. So we start at 350. Remember, that's the thing we always start looking at first. So right here, I'm going to circle, including the sign, the 350. So that means it's positive 350. So positive 350 is going to be right about here, in between 3 and 4, okay? From there, we're going to go up 50 cents per 1 mile. So if we go 1 mile, how much is that going to be? Well, that's going to be a total of $4 because you have the $3.50 for the flat fee, right? Hold on, let me write this differently. Okay, so off to the side, I went ahead and wrote the equation. So if we're talking about 1 mile, then all you're really doing here is putting in y equals 0.50 times 1 plus the $3.50. Sorry, I had to make that a little smaller. And I'm going to erase that right here so that you can see clearly that I'm saying 1 goes right here, and now it's going to be plus the $3.50 flat fee, okay? So now let's go ahead and just solve that out, work out the math portion of it. So we get y equals 50 cents plus $3.50, which means y equals $4, okay? So what that means is if you're looking at it in a table, when x is 1, y is 4, okay? So this is how you get the ordered pair y, 1 and 4. So now let's think about it. What would 2 be? Well, we would just have to add 50 cents, right? So if you go over to the 2 and you go up, oops, try that again. You go up here. 3 would be over 3, up another 50 cents, which puts you at 5. From here, we're just going to go ahead and connect that line right here. Oops. And that line could keep going and going and going. Like that. Perfect. Okay. So there we go. I went ahead and cleaned it up. So that's how you're going to get your line from the graph. And now the last part is really going to be to interpret, which we've basically already done. As you can see, the slope represents the 50-cent cost per mile, and the Y-intercept represents the $3.50 flat fee. So hopefully that helped you out, and good luck and be wonderful. You can always do the practice problems on page 202, the guided practice, numbers 1 and 2, and that will help you practice. Thanks so much for listening. Have a great day.